In this video, we are going to learn about why meshing is the most important concept in analysis. There are generally two types of bodies. One is rigid and other is flexible. A rigid body is defined as a body on which the distance between any 2 points in the body never changes whatever the load applied on it. This simply means it doesn't deform for any external loads. But in real life, no body is rigid. Every body is flexible. A flexible body is defined as a body on which the distance between any 2 points will always change whenever the load is applied on it. So analysis is done mainly to flexible bodies. The freedom of movement in any direction for a particle is a vague definition for degrees of freedom. DOF tells the solver the number of equations to be solved to get the results. DOF also depends upon the type of analysis implemented. For a 3D element in static structural, have 6 degrees of freedom for the same 3D element in. Since DOF depends upon many other parameters, it will be discussed in further videos. Since in rigid bodies, the distance between any 2 points will be equal even if any external load is applied on it. Hence, all particles in the body will move as a single system, so it will have only 6 degrees of freedom, 3 translation and 3 rotation. But in a flexible body, every particle will have different degrees of freedom since there is no constraint for any 2 particles in a flexible body. Hence, a flexible body will always have infinite degrees of freedom. For this, discretization technique helps to bring this infinite degrees of freedom to finite degrees of freedom by dividing the whole geometry into smaller elements. And this whole process is called meshing. And the calculations are done based on the nodes which are interconnected by the elements. To find the area of this rectangle box, we have a formula. But to find the area of this curve, we don't have any formula. To find the area of this curve, we need to find the equation of this curve and integrate between the points on y-axis. In this example, the area under the curve is found out by integration technique. This technique can't be used by all types of curves because many curves don't have any equation. Like this curve in this example doesn't have any equation, so it has to be solved by approximation technique. In this example, the area is divided into 10 rectangles. As we know the areas of rectangle, we can approximate the area of the curve, and the shaded region is error for the area. In this, we further divided the error region into triangles so that we could decrease the error in the answer. The more divisions we make, lesser the error would be. Any CAE software uses this approximation technique for meshing. The results of any CAE software using this technique will always be approximate. They will never be exact. In the next video, we will talk about what methods does a CAE software use for calculation of results.